All right, so to start, I'm going to bring in the reference image. And all we're doing in this exercise is taking this image and using it so we can start modeling our ceiling light. Now the ceiling light's going to have a bit of a frame here. It has the light, and in reality, it actually has a box here. So you can connect it. If you look at it from the side, these little clips actually go into the ceiling and fix it in. Now, for this particular 3D model, we're just creating the face of it because that's what I want to use as a block to put within a space so I can put the ceiling lights using a script. So what I'll do here is let's start. Let's create this design. Now the first things is the units. I'll be using inches. And so we have this. Now let's get into how this is going to be developed. The first thing that we bring in, if we want to change the location, we'll go to construct point. Then I like to bring in an empty point component because we can change that location if we use this. Now I do create another copy and then go like this. So we can work off of this one and then we can change this one if we want to. So now that we have this point, when you create a light, you want to have a reference plane. So what I'll do is I'll go to a X, Y plane and locate it right at that point. All right, so now that we have that reference plane, let's first create the rectangle. But this rectangle will go rectangle with 2 points. We'll be moving it like this, taking this point and moving it both in the X and Y and negative X and Y. So we'll go here to move this point. In which direction? We'll go to X, Y vector, and now we can give it a size. So if it's the dimensions here, we have 8. Well, what we'll do is we'll create an 8.00 and 8.00, so it's a square. Now what we need to do is divide it by 2. So now it's 8. Since we're doing it both positive and negative, I'll actually bring in a divide by 2. And now we can divide both of these by 2. Now we can move that point by 4 and 4. We'll also do the same thing in the negative direction. So I'll take this, copy it down here, and I'll bring in a negative component. Now we can use that as the input. So now we have 2 points that we can use, including this plane as the input. And now these 2 points become the rectangle. So now we can disable preview here and we'll see that this is going to be the X size and the Y size. Now, if you want it to be a square, we keep them the same. If you want it to be a rectangle, we can change the aspect ratio. Now, we'll take this and we will offset it to the inside. Now, what I'll do is I'll bring in offset curve. It's offsetting to the outside, so I'll go negative because if we look at our diagram, this is the outside face. So if this is 8 and we want to offset to the inside, just go 0.5 or so. In reality, you'll always have a bit of a radius no matter how small it is. And then this one looks like it has a radius, but it's a little bit larger than the one on the outside. So we can account for that by bringing in a fillet. And that's going to fillet a curve, which we can do 0.125. Let's do that again. 0.125. We can use that as the radius and we can do it to the outside one. And what happens is when we go from here to here, This is the new one. This is the old one. So we can disable the preview on that one. Now we're going to bring this out here because now we can take this, slide it down, tap Alt. So now we've done this twice. Now we're going to, rather than do it to that original one, we wanted to do it to the offset one, which we can have as a larger one. So the same thing that we did here, this is the old one, so we're not previewing it. This is the old one. Now we can look at both of these. Now I like to organize them a little bit so we don't have too many wires overlapping. I also tend to disable the preview if I don't want it to get too confusing. All right, so now we have these two. What we need to do is create a surface there. So boundary surfaces between this one and this one. What happens here is that they're overlapping. It's looking at them as two separate ones, so it's creating two overlapping surfaces. So we either flatten the input or we can also graft one of the sides. But I think flattening it gives us the result we want. So we can disable the preview on some of this stuff, but here's the one we don't want to disable the preview on, this one, because that's actually going to serve as the light. So what we need to do is take this, we'll go to extrude. We'll extrude that surface up. So when you extrude, you need a direction. So the vector Z is what we'll use. And now we'll just extrude it by 2.5. It's going to be a little bit big. We'll do 0.5. And I like to use a few decimal points so we have more numbers to work with. This. Now we can disable the preview on that original surface because we already extruded it. Now we have it here as a solid. And what I personally like about parametric design is that we can make our decisions after we've made the script. We can change some of those. So we'll do 0.5 here. We'll do 0.25 on the outside. Next is going to be the light. So we have the outside frame. The light needs to be in this location. So what we'll do is we'll take this, copy it up here, use that as the input. We don't necessarily need to flatten it because it's only one of them. Now when we preview it, you'll see that we basically just created a boundary surface around that perimeter, which now we need to move up because we don't want the light to be flush here. We want it to be inserted a little bit. So now I'll go to move. And we want to move it up to here so we can just use this component. And we can use this as what we want to move. So now we can disable the preview. Notice that we've moved it up. Now we're going to extrude it down by half. So if this is 0.244, then we can extrude this surface. This is positive, so if I plug that in, it'll actually extrude it up. So now I'll go negative, which means down. And it'll be flush because it's the exact same amount. And then here, divide by 2. Or you could do divide by 3 or divide by whatever number if you don't want it to be the exact same. And if you do divide by 3, it'll just be smaller. But it will never reach 0. So this kind of gives you that idea. So the minimum would be 1 to keep it the same. And as you increase it, it gets smaller. You can also create a range of them. So the idea on this is to take this, which I like to basically extract this extrusion into this geometry component, so I can know that that is one that to keep an eye out. Same with this one. We'll group it, move it to the right. Now we can disable preview on all this, and you'll see that this is going to be the location. Now I'm actually seeing that we went the opposite way. So we extruded this up, and I actually should have extruded it down. Why? Because wherever that is located, that would be the ceiling. And so to fix this, we're just going to take this extrude up and go down. And now here it's the opposite, because here it's negative. So we want it to go up by a positive number. It actually just needs to be extruded down. So let's see here. This is the original, and it just needs to be extruded down by this divided by 2. It was easier this way than before. This is going to be the number. So notice that even though I made a mistake from the way that I started, I was able to kind of fix that by making some of those adjustments. So let's go here to disable preview. And now let's bring in some custom previews, so we can add a little bit of color using a color swatch. Now, sometimes I use different kinds of color swatches for materials. For this one, we'll keep it simple. We'll use this color swatch, disable the preview on the input, and then we'll do the same thing down here. So slide down, tap Alt, and plug this in. Now we can change that. All right, so at this stage, we've basically created the light. Now, how do we turn this into an array that we can find one spot and then create a set of them here? So at this stage, we need to just array it. What we'll do is, I'll show you how to do it using a series component. So first things first is, we know that this point creates that light. So if we want to create an array, we first need to move those points to create a grid. What I'll do is I'll go to a move component, and I will move this point in the X direction. And I'll give it a specific spacing. So I'll just say 100. Now we've created one more. Let's say we want to create a series of them here. Well, that's what I'll do here is bring in a series component, which all it does is it creates multiple numbers at once. This one only has 100. This one is going to step by 100. How many times? Well, we'll just say 4 times. And so we have, rather than 100, we have 0, 100, 200, and 300. So we can use that to create that grid, and we can expand it this way. So we're basically creating an array in a linear dimension, the X direction. And now we're going to do the same thing and move these points. And this is how grids are made. In which direction? In the Y direction. So now we can use the spacing this for the X direction. And now we'll copy this up for the Y direction and move these points, not in the X direction, but in the Y direction. Now what's happening here is we need to graft the input And now we've basically created a grid array with 9 in, or this slider being in the Y direction, this slider being in the X direction, and here we have the spacing for both of those. So now that we've created this, obviously we can do this with a grid, but I think this serves as an exercise showing you how series can actually be used to create some of those base geometries. So now that we have those points, we're going to move from this point to all of those points. So I'll show you that with a vector. A vector is nothing more than a direction and a magnitude. So we're going to start at this point and end at all of these points. So from here to here, from here to here, from here to here. And it's going to have 24 different line segments that we could use as a vector to move all of these. Notice that it's moving it from one point to multiple points, from one point to multiple points. And you can tell that by the way that this wire is set up. It has a dashed line, which means that there's like sets of them going through the wire. And so now that we did that with this one, we'll do that again, the bottom one. And now we can see that we have a grid array. And let's just decrease the size so you can see the spacing of it and the extents. Spacing. And if you want it to be a square, obviously you could just use the same numbers for both X and Y, kind of like this. And same for this, the count and spacing. If you want it to be square, you just make them the same. And now we can override this one and this one. Like I said, when I have this wire that goes from here all the way over here, it just doesn't look good. And it's not so much about making it look good, it's more about clarity. And we can always figure out where that came from when we select this. So I just tend to disable the preview to kind of clean it up a little bit. I do sometimes get people telling me, hey, how do you make your scripts clean and organized? I don't think that I'm that organized, but I think that's something that I should go over a little bit more, is how to attempt to try to keep things organized and functional at the same time. All right. So with that, we have most of what we need. We have the location, this point. And now what's cool is, let's say you have a roof. Let's try to do this here. We'll make this a floor. We'll do extrude curve. We'll extrude these, we'll just say 10 feet. And copy this up. And now I will set one point here. And I'll go here in Grasshopper, bring in a different point. I'll go to set one point and set this here. So notice that now that we move this here, I can just say 2 feet away from the wall. We can now play around with the array. Now the count, not as important right now as the spacing. And obviously this one is right up to the wall, so we can go here, let's say another 2 feet. Just make sure that we're 2 feet from the wall. Now, the thing I want to make sure to do is that it bakes into its own layer. So this way, when you bring it into your project, you can assign an emissive material to your lights, and that should function as a way to bring in light into your projects and using it parametrically. Now, this is a fairly simple exercise, so you can use this exercise to create other blocks that are useful for architecture, but for the most part, this one will bring light into your project just by using a single point. Lastly, this is what I wanted to share, is if you just want it to be a single light, we just go to 1, 1 and just use that as the location. Oh, here's one other thing. This is going to be a cool one. If the number of the radius for the outside, we make it larger. So let's say if 8 inches is how big the thing is, so I'll make max of 8. If I fill it the radius of the outside and then fill it the radius of the inside one, now we also have the ability to create circular lights, or some that have a different design. So we can change some of these things depending on sometimes the language that you have within your design. You may not want square ones, you may want circular ones. So with this one, that's how we take care of that. All right, what I'll do now is I'll clean it up. I'll have a bake feature so you can toggle true and false and turn this on and off. But hopefully this beginning exercise showed you a little bit of the power of parametric design and how you can create blocks to save time for your designs and also to create a library of things. I think this is a useful thing for architects, is not having to recreate everything all over again, but being able to program your steps to your satisfaction. So thank you very much for being here. I'll show you the cleanup process. If you want to download this, it'll be available on my website along with other useful scripts for this month. Other than that, let me know in the comments below if you have any questions or adjustments or ideas, and I hope to see you on the next one. So I was cleaning this up and I came across a really good idea to make this more functional. Here's how it was at the beginning. At the beginning, we had it so let's disable the preview on this and enable this one. We have the ability to create more extents on this by changing the location. Now that's really useful in the sense that we can create a very easy array. But what happens is if you have a boundary, let's say like here, if I set the point up here, it's going to be difficult to figure out how to offset them exactly from the outside face of that wall. So what I did was I created another ability, which was to bring in your own polyline of where the boundary is. Then it's offset, and using that grid that I created off of that surface, then arraying it onto that. Let me show you why this is really useful. And if we go here and disable the preview on the original and then preview this one, you'll see that now we have the ability to do this. We can now offset from the outside face to the inside, creating a gap, which is a typical thing that you'll see because when you have a light right up to the wall, then it won't be able to spread all the way to the ground. So if we have this offset, it can kind of take care of that issue. And then here we have the array. So this one is way more useful, way more practical. The only thing that you need to make sure to do is add your own curve. So with that being said, this has two functionalities. One is setting your own point and arraying it in the X and Y this way. Or we have the ability to set your own polyline as your input. So then you can bake your output that's out here.